it's so basic you might not realize what it's really asking. But do you guys see how it really is just showing you why the order you put things in matters? Right? That's the whole point of number one. So in every case, I'm still talking about the same triangles. I'm just putting their identifying vertices in different orders. So does somebody think they can see what 1A is? Yeah, so T, R, S, K, J, L. Beautiful. Does anyone not see the pattern there, the reason that we're... Okay. Sorry, this weekend kind of got away from me and I was like, holy crap. Does everybody see that? Does everybody see that again? So if I say TRS, you go here and you go, okay, T, R, S, K, J, L. Okay. Because they set up for me the congruency statement, which tells me which vertices kind of match with the other ones. Is that okay? So that number one is just really just slap you in the face with this saying, hey, when you say one triangle is congruent or similar to another one, you have to make sure that you actually line things up correctly. Okay. Oh, number two, is this the one somebody pointed out to me? I think for some reason, okay. I didn't need to give you a picture, but I did. And then it didn't match up with the ordering here. I don't know if you guys really notice that. So LMN and PRQ. Do you see how LM is the long side and PR is the short side? So I believe this should have been PQR. I think what I did was I had this and I'm like, let me give them a picture. And then I gave you a picture where things weren't in the right place. You guys gonna follow? I didn't have to give you the picture because number one sort of sets up how you can find what you need. So if we answer this from the statement I gave you, what is the key thing about angle, side, angle? Do I just need two angles and a side, or do I have to be more careful?
The side has to be sandwiched between the angles.
Beautiful sandwich. I love that. You guys know what a sandwich is? A sandwich is a really tasty sandwich. So anyway, so it's got to be literally like I could use angle L, side LM, and angle M. It's got to be the angles on either side of that side, right? Okay. So I didn't mean for number two to be tricky. I'm really sorry. I gave you a picture without double checking to make sure that the letters matched. I'm not sure if everybody sees the issue. But from the picture, which side in the first triangle, which side in this triangle lines up with LM? Yeah, and to be really specific, PQ. Yeah? So, I don't know how many of you guys attempted this problem. I know at least one person did because they pointed out to me how silly it was. They didn't use that language, but I don't blame them if they thought it. Really, to make sure you guys understand, this should really be PQR to line up with the picture, if I remember correctly. PQ, yeah. PQ is LM, MN is QR. Yeah, okay. Now the picture and the statement line up, and now it might be easier to answer the question. So I think originally I didn't have the picture, and I was like, let me put a picture here. So is number two, yes?
By statement, you just mean, like you said, like angle PQ is congruent to angle M.
Yeah, three congruent statements. So like angle, say angle.
Angle PQ.
Careful. PQ is not an angle. You mean side PQ? So there's angle P, angle Q, angle R. There's side PQ, side QR, and side RP. Yes? Are you with me, babe?
Yeah.
Okay. So one thing that I would need could be, I need side LM to be congruent to side PQ.
So then it would be,
And if I start there, I need the angles on either side of it to be congruent. Yes? Yeah.
When you write the angle, do you write a PQ line for Q, or do you just write angle Q?
Oh, it's up to you. In this case, I could just write angle Q. You guys see why?
Is there any scenario where that would be wrong though?
Oh, hell yeah. If there was another line coming off of here, then that's not specific enough. If it was possible that I could mean either this one or this one, you see how there are really two angle Qs? But why is that not a problem here? Because when I say angle Q, I mean the angle that's where? In the triangle, yes? Okay. You guys kind of with me? So if you say angle RQP, and somebody else says angle Q, you both just said the same thing. Because in this problem, we're talking about in the triangle. Is that cool?
mm-hmm.
You only have to be careful if either you could mean the big ass freaking angle, wow, yes? Or if there's another line coming off of here, and then you're like, well, there's three angles in there. Which one is Q? Then you have to use the three letters to really make sure that you've kind of circumnavigated the right angle. Yes? That wasn't the right word, but I just wanted to say it. Okay. Is that all right? Are you guys okay? Okay. Feel intruded.
Can you give an example? Like it'd be angle PT.
Yeah, you ready? Okay. So, Peyton, give me whatever you want to start with. Give me two sides or two angles that need to be congruent, however you want to do it. Unless you don't feel comfortable, I can do it.
I don't think I understand what that's.
Oh, okay. In order to use this, angle side angle, congruence property, I need to get an angle from this one that's congruent to this one, a side that's congruent, and an angle that's congruent. But angle side angle specifically says you would need to have angle side angle and angle. Jeff, you can do it, Jeff. You're funny, Jeff. You would need angle side angle and angle side angle. You would have to have the included side between the two angles you pick. So one thing you could do to keep it straight is, do you see how LM and PQ go together? So then LM, the measure of LM would have to equal the measure of PQ, would be congruent, sorry. Yes? What two angles are off of the two sides of that side? It's a weird way to say that. What two angles? So for example, here's LM. Is angle N next to this side? No, what two angles are next to that side? Angle M and L. Okay, so then angle M would have to equal angle Q, or be congruent to, yes? And angle L would have to be congruent to angle P. So whatever you pick, this is kind of nifty. If you pick side LM and side PQ, then you basically need angle L to be equal to angle Q, congruent. Let me take a moment. I just looked at the letter P and said Q. So let me stop. LM congruent to PQ. Angle L congruent to angle P. Angle M congruent to angle Q. So then you have the angle on this side of LM, the angle on this side of PQ, the angle on this side of LM, the angle on this side of PQ. That's angle side angle. Two angles are congruent, and the side that they connect, that connects them, is congruent.
So that counts as one. Just four.
Say again, sorry?
That counts as one, isn't it?
No, that's three.
Oh.
Yeah, that's one congruent statement. This is congruent to that. That's a second congruent statement, and that's a third congruent statement.
Okay.
Yep. So you don't need three sets of three congruent statements.
Oh, okay. It can be the same, just written.
Yeah, so how many different answers are this? There's a few, because you can pick different sides to kind of focus on. Yeah. But the real heart of this idea is what I just said. It doesn't matter which side and which corresponding angles you use, as long as you get two angles and one side between the two. So that's one way you could answer number 2. There are effectively 2 other ways because there's 2 other sides that it didn't use. Yeah? For each triangle. Okay. Is that okay for you guys? Is that okay? So number 1 and number 2 are cool. Is that true? Okay. Number 1 is one of those problems that it might be too easy, and then you're like, he must mean there's more to it than that. So what's going on with number 3? 3A, let's say. Let's specify. That might have been very too open of a question. It's wide open. There are several ways to show.
It's
Second.
different.
Oh, is that you? Look at me all assuming things. Do, 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 do. You took a quiz, right? Okay. Yeah. Okay. So you could use any of the congruence methods to show this. I mean, what's the first thing that jumps out at you for number 3A? Well, there's a linchpin here. There's a certain thing that needs to happen, and you're done. Yes.
Subtract 180. I mean,
Yeah, it's all about the angles in this one. Did I give you any way to figure out, for example, side BC? Is side, is it a valid congruence property? Yes. If the 3 sides of a triangle are the same measure as the 3 sides of another triangle, those 2 triangles are congruent. Totally. Scale factor 1, same triangle. Right, same size triangle. But I didn't give you a way to figure out that last side, so you can't use side. So now you gotta start focusing on angles. Do I have the right angle in both cases? What would this be? What do I have here? Angle, side, yes? And that is appropriately named the ASS. In high school it'd be SSA, because people can't handle ass in high school. But that makes more sense to me. It's the one situation that it doesn't guarantee congruence. How about the other triangle? Is it set up in weighting? Is it set up good? What property could I use based on what I'm given here? Side angle side. Is that a good congruence property? Is that valid? Yes. So what angle do I need to figure out in the first triangle to be able to use that? Yeah, angle A. Okay. Whenever we do a problem like that, loosely together, I kind of led you guys down that road. You need to pay attention to what it is that motivated me to do the next thing, right? What in this problem led me down? That first triangle doesn't give me the correct stuff. The second triangle does. Oh, good. So then which angle do I need in the first triangle? Let me focus on that. So, what kind of triangle must this be? Isosceles. Could it be equilateral? No. Why not? Why can't it be equilateral? You guys know. How big is each angle in an equilateral triangle? Because it's equiangular too. All the angles in an equilateral triangle have to be the same because they have the same mouth opening. So what's every angle gotta be? 60. So I know it's not equilateral. But it's gotta be isosceles. Because by definition, those 2 sides are the same length. So it's at least isosceles, and I know it's only isosceles. So what is this angle? 70. So what is the top angle? 40 degrees. That's 140. I need 40 more to make 180. So can I use side, angle, side now? 545, 545. Okay. So later today when it's 545, you go, holy shit. It's the time Jeff spoke of. Yes.
What's the, like, how do you know what the angles are because it's isosceles? Like,
Oh, so isosceles triangles, they have the same side lengths here, which means this mouth and this mouth. So this side length is the same as this side length, yes? So this mouth and this mouth have to open the same amount. So this angle has to be the same as that angle. So I knew that was 70, which meant I knew that was 70. And if those make 140, what's left for the other one? 40. Does it make sense? Okay. So in general, you can't just say, oh, it looks isosceles. I have to give you enough information, and I did. Those sides are the same length. You know it's at least isosceles. Which means at least those base angles are the same. Yes? Is that okay? The important thing on that problem was, what did I look for at the beginning? I'm looking for a congruence property. SAS, SSS, ASA. And triangle FED kind of sets up side, angle, side. And I'm like, oh cool, if I could just figure out that top angle, I can see if it works. Yeah? So if this would have been anything other than 70 degrees, is it possible those two triangles are congruent? If this was anything except 70 degrees, nope. Because only that leads to the other one being 40, which is what we need here. Yeah. Okay. What about part B? Part B is a little tricky.
I think no,
Okay,
they're
why?
not congruent because, well,
What's the, yeah, go ahead.
the one on the right, if you had to like turn it to both the 65s to be on the top, like the first one, the 4 would be on the left side of the triangle and at the top.
Beautiful.
And if it's isosceles, then this, like these sides are gonna need to be longer than the top.
Kick
part.
ass. Okay, so that was
That makes
beautiful.
sense.
That's no total. That is one kind of way to go down. Every way you look at this problem must start with what? Let me think. Yeah, pretty much must start with this realization. 4 is in the wrong place. Now you can't just say 4 is in the wrong place. So no. Then you have to see. Okay, could the other side still match? Could yes.
So if I like wrote down basically what I said, would that be like what you're asking for?
Yes,
No problem?
you get a little tear. No, yeah. All right, I really want you guys to really get this. Why in this triangle, like Justinia said, why do I know those sides have to be longer than 4? Can anyone tell me what this angle is here? 50. Kick ass. How did you get that, Pete? Added 65 to 65, and you saw what was left over. Yeah? Is everybody with me? So that is 50, which means these mouths here open wider than the one that has a 4 in it. Yes? Really, that idea of an angle being a mouth opening and the side being the stick in the mouth, that just carries you through so much. 50 opens up and has a 4 there. 65 is going to be smaller or bigger than 4, the stick that goes in it. 50 opens up so there's a 4 there. 65, could it also have a 4 there? No. It's a bigger mouth, yes? So these sides will be bigger than 4. Yes? This is not 4. This is bigger than 4. This is bigger than 4. But this is 4, 4, and what would this side be? Not what the value is. Is it bigger or smaller than 4? Smaller. So is there any way those two are congruent? No, because the sides are different ones. There was, the funny thing is, there is one side that's the same length, but then the other two are different. So it cannot be congruent. Now, how many ways is there to say what I just said? I think I effectively said what Justinia said, but we said it two different ways. Yes?
Whenever we answer the question, can we say like, oh, the angle side angles don't match up, like,
Sure. As long as you show me some work to how you got to the point where you can say that. The one problem with that is that's not the only way to be congruent. But if angle side angle, I need this to make sense. If you pick one angle and then the side and an angle, you might have picked the wrong angle side angle to compare it to in the other triangle. Does that make sense? So you have to be a little careful about. That's a little too loose. It doesn't really lead you to be able to say they're not congruent. Okay. The easiest way to show two triangles are not congruent is to show that at least one of the sides is different than what it should be. Right? If this is 3, 4, 5 and this one's 3, 4, 6, hey, it's not congruent. Is there another way to do 3B? Almost definitely, but we'll see. Oh, this is the practice test, and then this is just a copy of this, and let's see what was on it. Alright. What did I say on the key? Oh, yeah, okay. Same thing. So if there's no questions on that. By the way, anytime anybody has a specific question, because I'm just going off of Leia's request to kind of go step by step. If anybody has a specific question from something else or on the practice test, feel free to ask that. Yes? I'm just gonna, if nobody has any questions, we're just gonna kind of march through. Okay. So did anybody try out number 4 there? I mean, one thing we could do right now, how many of you guys tried out some of the problems on the practice test? If you wanted to, we could, right now, everybody could work on number 4, and then I could kind of come in afterwards. You guys could work with other people if you want to. It's entirely up to you. I always want these review days to be where you get what you need out of it. So if you want to, try number 4 out, and then I'll come in, we'll do it together here in a minute. Yes, sir. Oh. So one big thing about this is C is 1, 2, 3, 4 different angles. You know what I mean? Now I know from what you're saying what you meant, but say something like BCA is going to be ECD because they're across from each other or something. You don't have to remember the angles. Yeah, and then what does that lead to? So since they have 40 and they have this, then what does that match? What is that match in terms of similarity property? There was one that sounded like you were going to get car insurance, and then we cut it down to it sounded like you needed help to, so it was AAA, and then we cut it down to AA, yes? So what you've got is, you've got angling, right, angle, which means you have angle,
Right,
which would mean it's definitely similar.
okay.
Yeah.
So that's.
So I took a point up because I kinda knew where you were headed, you just didn't quite get there.
Okay,
Okay, good.
yeah, thank you.
You're welcome. By the way, there's something you can do on 4B that you can't do on 4A. Thanks, Jeff. Sorry. Who's got 4A? Who's got 4A figured out? Anybody? Yeah, hold on. Are you guys still working on it? Or is anybody working on it? You guys all doing your own thing? Okay. So what you got?
I was just curious, I don't remember what it's called when two angles are like across each other. and then
Oh, be
they-
careful, that's not happening in 4A.
Okay, that's what I was gonna ask, if that was it.
There's-
What's the name for it, so I know?
Oh, vertical angles. Is that what you mean? Like, the one on the quiz, there was vertical angles.
Yeah, I just didn't know.
Like a bow tie, yes?
Yeah.
And those angles would be the same, those are vertical angles. That's not what happened here. XZY does not have to be congruent to VZW. It really just depends on how much these go up and down. But if I have this and I have this, the four angles I just made, they have to be congruent to the angle across from them, yes? So the angle here has got to be congruent to the angle down there and this way also, yeah? Is that cool? Okay. So that's not going into play here. What congruence properties are they? Can somebody remind me? I know this is similarity, but I'm gonna get there. I'll start. Side, side, side.
Side angle, side,
Side angle, side.
angle, side angle.
Angle, side angle. Okay. For similarity, we have angle, 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 which we said to ourselves, well, that's silly. All I need is angle, angle. Because then the third A is given to me, yes? But we also have side, angle, side. And what the shit does that mean with similarity? That means that I need to have the ratio of side to side, and the ratio of side to side is the same, and then the angle between them is congruent. What sides did I give you in each triangle? What angle is between them? So I know the angle, correct?
Yeah.
Are the sides on either side of that angle in a ratio, in proportion?
Yeah.
What's 4 to 6? Reduce that. 4 to 6.
6 divided by.
Or 6 to 4, sure. Reduce it.
6 divided by 1.5 is 4.
No, stop it.
Wait,
Reduce 6 over 4. Reduce 6 over 4. Not give me a decimal, just reduce it. 3 over 2. Now, reduce 9 over 6.
3 over 2.
So they're both the same ratio. Now, what you said is fine. If you actually just divide them, you get 1.5 for the same, so they both have the same scale factor, which means these two sides and these two sides set up a similarity proportion kind of thing, yes? So I have side, angle, side. Done. Could you ever figure out, well, that's silly, Jeff. Of course you could. I just realized something. You could do the same, now, real quick. 4B. Do I give you any of the freaking angles? So you let go of that, yeah? What's the only thing you have then? Huh? Sides. And what would tell you they are similar? What must be true? Yeah, they all have to have the same scale factor, right? So if you look at the base, do you see how one is kind of like the other one just turned around and blown up? Do you see that? Do you see how? Well, here, let's do this. These are kind of gross, do you agree? How would you scale it up so it wasn't so gross anymore? What would you do to the triangle? Would you triple it? Double it, yes? What do you get when you double every side in that triangle? Double this, what do you get? 3, double that? 4, double that? 5. So what similarity property could I use? Well, just the fact the scale factor is the same, side, there's the scale factor just works all the way across. So one triangle is just the other one doubled. Is that cool? When I give you all the sides, you can just straight up go to scale factor. You have to be careful, because if I, was just being silly and I went, well, twice that is 5, but twice 2 is not 3, oh shit, no, it's just, you gotta be careful if it's turned around. Yes? Do you see what I mean? Is that okay? Okay. Sometimes I'll ask people if that's okay, and I don't really believe when they say this, but we'll see.
I'm just thinking about other stuff right now, so.
Oh, here we go, I'm sorry, I don't mean to, it's just a general statement about when you're a teacher, don't try to assume anything about any looks you get from students. Did I tell you about a real quick story? Did you tell about the one time I had a girl, she would sit in the front row, and I thought she hated my guts. The entire semester, she was just like, she never said anything, and I was just like, she really just hates everything I'm doing, so, alright. At the end of the semester, she turns to the final and she's like, Mr. Waller, thank you, this was a great class. And she walked in and I was like, what the hell just happened? She never said a word to me the whole semester. Anyway, so I'm like, okay, you can't take anything you're seeing personally, because everybody's got their own life, they all got kind of stuff going on, so. Is number 4 okay then? Okay. What about number 5? What's a good idea in number 5?
Can you give us time to do it again? And then
Oh yeah, sure, but just to get you started, what's a good idea in number 5?
Draw it.
Yes, so go for it. If you're not a good artist, you don't have to actually draw a tree, you just draw a big line. And say this is the skinniest damn tree in existence. But then I want a very artistic pole. Gotta draw. Trees had a rough life. Put the sun up here. It's pretty much the same. Yeah, it's the same. Yeah, same picture I drew on the answer to this. The shadow is 29 meters long. Vertical pole. So this is yeah, okay. I don't know what height this is. Eventually I want to know what height that is. But a little pole 3 meters tall casts a shadow that is 4 meters long. Now, does it make sense? Does it make sense that the shadow thing's cast at a certain time? Do you see how there's always going to be a triangle involved? So if you're walking along, you see a shadow of yourself down there, you can draw a line from your head to your shadow's head, back to your body, you just made a right triangle. Yes? What do you think is true about everything at a certain time of day, at the same location? What do you think is true about the triangles you can make with the shadow and the thing? Shadow on the pole, shadow on the tree, shadow on the person. What's true about those triangles? What do you think must be true? Are they all created for the same reason? Are they all created in the same way? Why are there shadows? Sun! And at a certain time of day, isn't the sunlight coming down at a certain angle? And that's why when the sun gets lower, the shadows get longer, because then this angle gets less in terms of straight here. I guess all with me. Shadows get really long. Have you ever played in front of a light? You got really close to it, you had your brother standing over there, and your shadow's huge. Oh, I'm gonna look at you. No. Okay. Or whoever. They say brother. I'm thinking about my little brothers. So what, is that cool? So that's the whole idea of a lot of things, is the fact that the sun actually creates right triangles everywhere. It's really neat if you stop and think about it. Every shadow you see, you connect it back, you made a right triangle. All of those triangles have to be similar. They all must be similar. If I had a person squatting at 3 feet and made a shadow and he stands up to 6 feet, then the triangle is gonna double. Does that make sense? So it's gotta be similar triangles. So what can you set up to figure out H? So if they are similar, what must be true about their sides? Scale factor, which you can just say, I can set up a proportion, yes? So like the height of the tree divided by the length of its shadow must equal the height of the pole divided by the length of its shadow. That's one proportion you can set up. How many other proportions? So many. They all will take you to, I'll set 2 of them up. Whatever 3 is multiplied to get H. And how do I figure that out? H divided by 3. That would be what I multiplied 3 by to get H. I've got to multiply 4 by the exact same thing, through or death. The exact same thing to get 29. That's all that says. Whatever I multiply 4 by to get 29 must be what I multiply 3 by to get H. How do I solve that? How do I solve that? You're all like, I'm not you, Jeff. I don't know how you solve it. Yeah, cross multiply. So, yeah, let's be silly. 4 times H equals 29 times 3, which is 87? Yes? Okay. Yay. And then divide by 4, and I get 21.75?
Yeah.
What is it? Meters. Now, I could have done this. Ooh, Jeff, I could have done this. The height of the tree divided by its shadow has to equal the height of the pole divided by its shadow. And look, when I cross multiply, don't I get the same equation I got over here? Don't I get 4H equals 87? So there's a whole lot of proportionality statements you can set up. Because there's a whole lot of sides, they'll all have to have the same multiplier. Maybe. Let me guess. Did you guys get that? I'm sorry, I might have worked on that too soon. Yeah, I love this very, I was going to say colorful, but it's got 2 colors. This little pop of color just out of nowhere. Okay. We've seen a situation like this before. I feel like we talked about this one, did we? Or was it just something similar? Oh, well, that's okay. So I tell you at the beginning they're similar, and I want you to find the remaining silent. So again, this is all about the proportionality statement. That seems to be important to me for some reason. Because number 7 is the same thing again, just the proportionality stuff, right? So in number 6, I've set up I've set them up visually so that they line up. Is that cool? If I just blow one of the triangles up, it becomes the other one, and I don't have to rotate it. I don't have to reflect it. Yes? Anyone just tell me in 6A what the scale factor is? 6. So what is psi RS?
6.
6.
6. I didn't tell you ln or RT. I'm sure. But what saves you? I need all the side lengths, yes? So I need side ln, I need side RT. And you're all like, yeah, I need more money. We all want something. How do I get that last side? Like ln, I could get that right away. How could I get ln? Multiply what by 6? Do I know its corresponding side in the other triangle? Yeah, good old Greek dude. Old Greek dude. So I can get RS by using the scale factor, and then I can get the last side of each triangle just by their own Pythagorean theorem. Now the great thing is I can get the little dude, and then I can do what you said. Yes. So if I get ln, I can just multiply by 6. I don't have to do another Pythagorean theorem for RST. Is that okay?
Is that the same thing for part B?
Sort of. Now they both kind of live in each other. So it's sort of like all part B is me taking this and plopping it in there, yeah? That's really all it is. So I still have 2 right triangles. Yes? It's a little bit trickier though. Well, it's a lot trickier, to be honest. Because now, can somebody give me one side that is in the larger triangle?
5.
I mean, I'll start us off. EF is in the larger triangle.
Oh, yeah.
You're good, you're good. I wasn't specific. Give me another side besides EF that's in the larger triangle. EI. Yeah, EI is in the larger triangle. What sucks about EI? It's made up of EG and GI. Yes? Okay, so a really good, smart thing to do is to label the things you don't know so then you can work with them. So this is where algebra helps out. So for example, you can call this, what do you want to call this here? Give it a letter name. A is crazy sauce. What about this whole thing? B? And then what about this little piece here? That's insane. There's no way for me to know. And what about this little piece here? I didn't see that coming. Okay. Can you get side D easy?
Yeah.
What else? Or what does it for you?
A squared plus B squared.
Yeah, old Greek dude again. How do you establish, so is everybody cool with that? You can get side D immediately. What do I do from there?
Find the proportion.
Yeah, the proportionality. So how do I find the scale factor? Thankfully, I got a complete ratio, yes. So what is it? What's the scale factor? Just scale, sure. Scale factor. Yes. Scale.
Times 2?
Do you?
Times
No. So, real quick. On that first triangle, what was the scale factor? Do it again. 6. Why? 18 divided by 3 is 6. So if you divide the sides that are similar, you get the scale factor. What 2 sides over here do I know are similar? There's only 2 that I have full information about. 5 and 3, yes? You can go either way you want to. So you can either say the scale factor is 3/5 small to big, or 5/3 big to small. Same way I could have said this is blow this one up by 6, or cut this by 1/6. Either way, yes? the answers you get are gonna be a little bit gross. You're gonna be okay. So real quick. If I'm going from the small triangle to the big, do you all agree with me that you would apply this? From the small to the big, I'm gonna multiply by 1 and something, so it gets a little bigger. What side in the big triangle is similar to GI? Was that L? I don't know. What side of the big triangle, I think it's supposed to be, is similar to GI? EI. So what do I do to 6 to figure out how long EI is? Multiply by 5/3. And what's really cool about that is 3 goes into 6. So go ahead and do that. See what you get for EI.
Yeah.
Jeff, shut up. Yeah, that's it. And now what I'm missing is B and C, right? All right, let's fill in what we know. I know that this whole thing here is 10 because we did 5/3 times 6. We got 10. So that's 10. How do I get B? And we got D. What'd you guys get for D, by the way? Something kind of gross, I think. What'll it be? 36 minus 9, 20. Square root of 27? Maybe? Anybody? Anybody try to figure out what D was?
Square root of 27.
Okay, good. That's what I got. Kind of gross, but it's okay. It's just a poor little number just sitting there, right? So how do I figure out what B is?
Times it by
Oh, sure. Yeah. So if I know that D is square root of 27, and I want to know what B is, I just take square root of 27 times the scale factor, 5/3. And you just have to write all that shit down. I'm not going to make you could simplify square root of 27, believe it or not. I'm not going to go into, we'll just real quickly. Isn't 27 9 times 3? Square root of 27 is the square root of 9 times the square root of 3 is 3 times the square root of 3. But you don't have to know how to do that. It's not part of our class. So you could just write 5 divided 27 over 3. Yes? Is that okay? There's one side left. C. How do I get C? Well, just visually, how do I get it? I take B, and I do what to get C? Subtract D. So even though they're gross, I don't care. Take B, 5 divided 27 over 3, and subtract by 27. You just write that, that's fine. I'm not gonna, you're fine. But you guys see visually, you can see whatever B is and whatever D is, it's subtracting to get what C is. Right? Okay. And the next problem, I'm almost certain that I actually looked at it. I stole it from the book. I think I might have looked at it with you guys momentarily. I don't think we actually did it. But it's a way to do things I would rather not do directly. So if I don't feel like fording this river, I can actually set up similar triangles and figure out how wide the river is, which is neat. It's a really cool little thing us humans did. So if you wanted to, it's not a bad idea to redraw the triangles. You could even rotate one of them so that they kind of like are directly just one blown up. So you can see better. So what am I saying? What's that little triangle? Let's draw it by itself. That little triangle is like this. Yes? Is that cool? And whatever angle this is, now if I take this triangle and rotate it so that it's like this, QPO. QPO. Let me see if I remember. Yeah. Then these two are the same size. What else do I know? I left something out. I know this little guy down here is 4. And I know, what else do I know? Oh, I know PO is 10. Oops, sorry guys. So I took the triangles out of the picture and I actually just rotated one of them so it was just directly the other one blown up. Now I can line things up better. Are we done? Yes.
For why they're similar, can we just say because they have 2 angles or 3 angles technically?
Yeah, well, exactly. So angle is a perfect way to say why. Now that I've gotten them kind of lined up, even before I lined them up, you knew that it had angle. So therefore, it's got the third angle, yes? So all you need is angle. Check. And now you can set up, using the scale factor, you can set up a proportionality statement. Is that cool? Okay. Or not even using scale, you can just set up a proportionality statement just directly. What's the side that I want to know? Yeah, PP. That would be the length across the river. Yeah. Okay. So if I was trying to construct a bridge to get across a chasm, it'd be really good to know ahead of time how long the bridge should be. It would suck to build it and then try to push it out and then, oh shit, it's too short. Oh shit. That's just one possible application. Is that okay? What could I set up here? What proportion can I set up?
4 over 10,
Yeah, 4 over 10 equals?
10 over x.
Beautiful, call this x, 10 over x. So this side to this side must be the same ratio as this side to that side. And then you just cross multiply, and it actually comes out to a nice number, believe it or not. Believe it or not, it comes out nice. Now, if you didn't want to do all that, you see how you would 10 divided by 4 is 2.5. So if I just did 2.5 times 10, I would get 25. That's the answer, but you'll get the same thing here. I think the next one might be the trippiest one. I don't know. Has anybody looked at number 8 yet? Oh, by the way, you get 25 up here, right? 25. Cha-bing. Oh, that's right. Did that translate well enough? Maybe. Oh yeah, it did. Cool. Real quick, why is triangle PAD similar to triangle PDE, similar to triangle PCF?
Parallel lines.
There's no parallel line similarities problem directly. But parallel lines do involve angles being congruent, correct? So parallel lines and a transversal, there's a whole bunch of congruent angles in there. You with me? So you can't just say parallel lines, therefore those triangles are congruent, because who knows how I drew the triangles? What angle does every one of those triangles have? So when you say P, I know what you mean, but APD, is that cool? Okay. So they automatically have one angle that's congruent. If you could just find one more angle that they all have congruence, you're done. That would be double A. Let me see. Yes.
They have, like PBA,
Yes.
PBB,
Yes. And what about those? What are those?
another name.
It's okay. Starts with a C. Crazy angles. No. Corresponding.
Wouldn't it be like equal opposite? There's one that is like something opposite angles,
Oh, alternate interior.
alternate interior.
Which would take me out of the triangle, so I don't wanna do that, but the corresponding is perfect. PDA, PEB, so if you forget the name on the test, you would just say, PDA is the same size as PEB, is the same as PFC, because they're all made the same way. Transversal parallel lines, go, yes? Okay, if you remember the word, you just gotta say that word, and you're good. Somebody with me? So part A is pretty straightforward, since it's parallel lines, and since the transversals make the triangles, then you have angle, angle in each one of them, so they're all similar. Now, how the shit? Look at 8B. What the hell, Jeff? What? What do you want from me, Jeff? What the shit? Jeff. So, I'm asking you, A from the top triangle times Y, which is a piece of this second tier triangle, equals B times A. Oh my God, Jeff, what do you want from me? So what the shit? How do you do that? Alright, what two triangles does AY and BX involve? There are two triangles that those involve. What are they? Where's A and X? Which triangle? PAD. And where's Y and B? PDE. Love it. Well, PEB. There you go. Yeah. Does everybody see that? So I focus on those two triangles. Since they are similar, can't I set up some proportions between the two? Alright, so again, on 8B, what was it that made me think to do that? The only thing I could do with the side lengths is use proportionality statements. I know those are similar triangles from part A. So I'm like, okay, those sides are in the top two triangles, so we focus on those and draw and write out a proportionality statement. So let's see. In the top triangle, what ratio can I create that involves the appropriate letters for the very top tiny triangle? I want a ratio. You can do it. Oh, okay, and we can use the little letter names to make it quicker, yes? PA is A. So A to, no? I can only look at this one triangle to set up oh, I see what you're doing. You could do that, I'm sorry, you could do that. So let's do it that way. I was thinking a certain way. So you did this side in the small. You gotta be really careful. How long is the side in this one? Yeah, so this is like this, yes? Equals this side in the small over what? X plus Y. Now, does that say what I said you should show?
No.
Does it have all the right letters in it? What did we do when we set up a proportionality statement a couple other times on the test? We immediately
Cross multiply.
try it. Do it. Cross multiply. Do it. Or don't. It's really up to you. Get what you're bringing. Wild thing. And I told you guys, I'm gonna, give you the instructions. You don't have to memorize the instructions. You don't have to memorize the construction instructions. Yes? Okay. How'd it go? Did you get it? Let me see.
AY equals X squared.
Yeah, buddy. So if you cross multiply, I'm gonna get AX plus AY equals XA plus XB. Is that cool?
Yeah.
Do you see something that's the same on both sides?
AX cancel out.
Yeah, if I subtract this, they cancel, and I get AY equals XB, which is what I was trying to show. Is that cool? It's okay if it's not clear. You can
I just don't know how to cancel it, multiply and cancel out, I don't remember that stuff.
Oh,
So when it's not numbers and it's just letters.
understood. Are you cool that AX is the same thing as XA? That's like saying 4 times 7 is the same thing as 7 times 4. Remember, commutative property. Whenever I see something that's the same on both sides of an equation, I can subtract it from both sides and it cancels. In fact, in general, I can subtract anything from both sides of an equation and the equality maintains. Yeah?
Whenever I multiply mine, I just put in parentheses A plus B and then I put X outside of it. and then I
Oh,
put-
yeah, so then you distribute, right?
Yeah.
Okay.
So I guess I didn't think to do that.
Yeah, distribute, because then things are free to move.
Distribute and cancel.
Yeah, distribute first, you get all these things that are free to move, and then they're free to kill each other. When I teach algebra, it's very violent.
So it comes out to AY plus BX
No, there's an equals in the middle, right?
equals BX.
And which is what we're trying to show. Done. And part C, to be honest, is the same idea, but just involving the big triangle, yes? So here, let me do this. Let me go ahead and give you this answer key. Because then I can see if what I did for number 9 makes sense. So part C, it involves the tiny and the big. Tiny and the big, and you cross multiply, pew pew, and then a bunch of shit cancels. Or not a bunch of, I'm sorry, just the AXs. Oh, this isn't crossed through, by the way. I'm sorry. I just realized what I did. I went ahead and did number 9 directly on the paper. That's just my pencil marks, yes? That's just the arcs to do this. I had to cut each of these sides in half, yes? I don't know if you guys are with me. So that's not marked through, I'm sorry. That's just pencil marks that I needed to make this. I think it was for this one, yeah. To make this median, yes? The middle. So number 9, I just had to cut each side in half. I just had to do that perpendicular bisector process. And the really neat thing is for every triangle, whenever you connect those together, they will always perfectly line up in the middle, and that middle, that's the geometric mean of the triangle. That's like the center of the triangle, which is neat. So anytime you do it for any triangle, their means will perfectly intersect in the middle. How would you do number 10? Yes.
So for my way, it was like a cheap little thing, cause I know on 90 degrees, the 45 is technically half of 90, so you can make then a 90-degree angle. with-
Well, how did you make a 90 degree?
Bisect an angle?
Bisect. Yeah. If you actually just do the draw line and then just perpendicular bisector of it, yes? Then you know it's a 90-degree angle. Then what do you do with that angle?
You do that.
Bisect it. And then you got a 45, yes. Is that okay? Yeah, so you construct a 90 degree, well, the only way we have to do that is draw a line and then make its perpendicular bisection. And then take any of those 90 you made and bisect it. And again, you'll have the instructions in there how to do it, yes? Okay. Yes?
Can you go over how to do 9?
Oh, so for each one, here, let me take a fresh one. So this one, I've done enough now that I actually kind of remember how to do it. But this is the perpendicular bisector. So if I do this bottom one, you have to open your compass. So that's just a little more than half. So just be sure I'm gonna open it just a little more. Open your compass so it's a little more than half as long as the line segment. Yes? Put the point at one end, make a arc there. Put the point at the other end, same opening, make an arc there. Then you put your point at either one of these, make a mark, make an arc, put it at the other one, make an arc, dadgummit. And then on the other side, do the same thing. Arc, I don't know if you guys, I'm sorry. And then put the marker here, the pointer there, arc. And then if you just connect those two intersections in the middle. So what I did was, oh, you don't have a straight edge, do you, Jeff? That's okay. What is that? Okay. Is that okay? I did a little quick, and you're going to have the instructions there, but that's the one we've done the most. So if I take the intersection of these two and the intersection of those two, normally I draw a line all the way through, but I didn't want to mess up my picture too much. So that would be the middle. I think I did that a little quick, so it might not be perfectly in the middle, but you with me? And then you do that for the other two sides. So right there, you would connect that top vertex to that midpoint I just found. You connect that. So you would take the vertex across from what I just found. So this is the midpoint. So you would take this vertex and draw a line to there. And now do that 2 more times. That's how I made those lines.
What do you notice about how they intersect?
Well, the cool thing is that I should have worded that better, but they actually perfectly intersect with each other. They should. There shouldn't be like a little thing in the middle. They shouldn't like intersect at this weird, right? They should perfectly intersect at one point. That was the thing I was trying to say. They should all intersect at one point. Yeah. And then I just added more on top of that. That's the geometric mean of the triangle. That's the geometric center of the triangle.
How come you draw it from the top vertex?
Oh yeah, because if I draw it from either of the other 2 vertices, they're just gonna follow that base, right? So I draw it from this vertex, it's just gonna follow that. I draw it from this vertex, it's just gonna follow. Draw it from the opposite vertex. So for this one, you're gonna draw from here, and for this one, you're gonna draw from here.
And that's what a median is?
The median is the midpoint. I'm sorry, the median is the segment joining the midpoints. So that line I just drew, that's the median.
Okay.
I wanted to give you something more than just,
Bisect this angle.
I wanted it to be a little more interesting. So I'll do the same thing on the test. Yay, Jeff. be up here if you need. What's up? No. Cause then we have a final. Huh? This is not the final coming up. This is just test three. Oh, cumulative, yeah. So I'll have a practice final, I'll give you guys on Wednesday. Monday, I'm sorry. Following Wednesday will be review, because Monday the 26th, of course, is a holiday. Much deserved, I believe. And then our final is actually Monday, June 2nd. So Wednesday, May 28th is gonna be a review for the final. It's also my little brother's birthday. So I'm gonna tell him, hey, we celebrated my review for fun. So you guys all good? So the one thing that was wrong on the homework sheet, I, for some reason, wanted to put a test on the holiday. And I figured, as a math teacher, I don't wanna make you hate me even more, so I thought maybe I should do that. So that's why we moved it to this Wednesday. Yes.
Did you remember, 23 in the book, on 14.3?
$23?
Yeah.
Oh, yeah. This one?
Uh-huh.
Okay. So Gwynnett's looking at an isosceles triangle. I thought in an isosceles triangle, the altitude, median, and the angle bisector are all supposed to be the same lines. Mine are all different. How should you respond? Oh, okay. So this one's kind of like the median is the one we just did. You got it? Right? If you look up altitude, angle bisector and all that, in an isosceles triangle, let me see if I can get you guys to board on this. This works. What she's saying works, but only for a specific angle. Which angle doesn't make sense that all three of those things would be the same thing?
No.
Which angle in the triangle?
Oh.
So, real quick, the median goes from a vertex to the midpoint of the opposite side. Is that cool? Does it have to be a right angle? No. If you look at the ones we did, they're not right angles. Could it be? Yes. Does it have to be? No. The altitude must be a right angle. That's the definition. The altitude is perpendicular to the base. So if I try to draw in the altitude for SL, it would be perpendicular to it going up to O. So OA looks to be the altitude.
So it would have to be angle I, right?
Yes, because that's the one that's symmetric both ways. So if I bisect it, that bisector ends up being perpendicular to the base, so it's also the altitude. And it's also the median, because that thing on the bottom cuts the bottom in half. So that's our mistake. So this problem I assigned so that you would read, you have to go back and read those things. In an isosceles triangle, it works if you use that one top angle. In this case, it's been turned over, but the one with the two congruent sides, yes. For the other ones, it doesn't have to do it. Yeah. It's just because that top angle is perfectly symmetric with everything else that's happening. So of course those would line up. If I use some other angle, it's not symmetric, so it doesn't have to line up. So it would also work in a equilateral triangle for the same reason. Cause then it's got beautiful symmetry. I just want somebody to write down, I don't know, what it? Google, no. Don't say that. Ask ChatGPT, what it? See you next time. Is that okay for you? So it was a little bit of independent reading stuff, cause I didn't really cover this directly. So I assigned this problem to me. If you go back and kind of look up, you know, like what the hell is she talking about in the first place? And then I would hope it would make sense why it would work for that one angle, but not necessarily the other ones. Yeah.
That's all I needed, thank you.
Oh, yeah, sure. So really, little, piece of advice, maybe your notes, you don't have to waste room with the construction steps, right? It's gonna give us, you know, so don't lose that. Alright, guys. See y'all Wednesday. Test you, as I do.
Have a good day.
See you. Okay.
Cheers, stapler.
Yeah. Yes.
And then I can email you about coming in.
Oh, yeah. I'll send you my schedule, or you can tell me if any of the days work. Yeah, I just was supposed to give a test today, but we're so behind in that class, I'm like, no.
Okay.
They were all very cool with it.
I'm sure.
Yeah,
Thank you.
you're welcome. You guys doing good? Figure something out?
I just did it really wrong. 14.2 homework.
Yeah?
And I'm like, I'm doing it, I'm like, how did you get? How, because I messed up one crucial part, laying it out, cause I laid it out differently than I normally do it, so it's just confusing me
Oh,
really
so
badly.
that error going everywhere.
Yeah,
I understand.
cause I messed up the first one, and I was using the answers we did. So I messed up every single thing out,
Understood.
so.
Well, the nice thing is, if you do that on a test, I'll just take myself out one first. And if you do everything right after that, I'm not. I was getting the teachers that are grading. Just take one mistake.
Yeah. Oh, this is what it is.
Some what?
You have 42.
There you go. Oh,
Yes, I did perfect.
no way.
If I did great the first
There's a certain kind of goat that'll fall over if it gets scared, you know that one? You should look at it. Fainting goats, yeah. You know what I'm thinking? These guys don't do that. No way. You have other animals? Understood? 50? How many do you have now? 3 goats. What happened to the one that they all? Gotcha. But you got some babies recently, okay?
Yes.
Good. Alright. Bodacious. Maybe more babies will come. Yeah.
About
See you.
14.3, because I don't have the textbook, I just have the computer. And
Yeah.
It gave us like a line.
Oh, I see what you
I
mean.
was like, can I just make my own one?
Just make your own one second.
Okay.
What were they asking you to do with it?
Something. Something.
I'm pretty sure they probably.
This one, number 1.
Even only so many constructed ones. Oh, I see, okay. Yeah, so just draw your own line.
Okay.
Line segment, and then give yourself a line and then do the construction. So it's the copying a line segment, yeah.
Okay.
Cool. There's nothing special about their line, you know.
Yeah.
All I'm gonna worry about is if the resulted line is the same, the segment is the same size.
Yeah.
So, yeah, is it? You guys good otherwise?
For now.
I don't think, my motivation in this one is so poor, because I'm like, I think I'm gonna do the A of the class, and if I don't do this
Oh,
too,
yeah.
so why am I even?
I understand that.
Oh,
I understand.
I have a question about this.
Yes,
It's somewhere. Give me a second.
no worries.
I don't put how many seconds, but why if or somewhere, right?
Shoot, let's see, because angle will be angles, alternate triangles, transversal lines, that has, go through parallel lines. Maybe so.
Okay.
Oh yeah, and so, yes, and so what? And because of what? You know what I mean? Like, I need you to tell me why what you highlighted was important. You know what I mean? Cause you can't use, for example, side angle, right?
Yeah.
Something like that.
Just because I didn't say there was like angle.
So something like that, something, therefore it's,
Okay.
similar because they so if you forget the letters, you can just still say they're similar because it isn't ASS or something, I mean, that's the one that you have to be careful about, right?
Yeah. I realized that. I think I heard you explain that to someone else.
Oh, okay.
Yeah, I don't know, maybe I just didn't really want, cause I forgot that.
Oh, yeah, got you. I know you know it, cause you used it on number 5.
Yeah.
But,
So you, like, I didn't realize that like scale factor applied still if you had just the sides. So.
oh, yeah, totally. Yeah, it's what saves you. Alright, so I'm gonna go back.